As game developers, we may be inspired to create based on something that we've seen that excites us or that provides us with certain emotions. These inspirations may come from other games that we've played, but they may also come from other mediums that we enjoy as well. If we spend some time and study that medium, we enable ourselves to create something that is similar in nature or that shares in that creativity. And in this video, we'll be using Godot 4 to recreate Diablo 4's inventory and character panel, including aspects of its itemization. Our goal is to better understand how the latest installation of the Diablo franchise accomplishes its implementation of items, inventories, and the way that information is presented to a player via the UI components. This project began purely as a UI study, but the more time I spent with the code, the more I was inspired to replicate some of Diablo's itemization. Even though it's not fully functional and isn't something I would toss directly into a game, I really love what I ended up with. I did quite a deep dive in the way Diablo's systems work, and I really wanted to get the same feel of the items in this example. Not only did that deep dive teach me a ton about Diablo, I learned a few things with Godot that will be helpful for me moving forward. Hopefully as I review what I've done, you'll learn a few things yourself. And this is just a snapshot of some of the reference images I used and compiled within PureRef to get a better understanding of the different components of the UI elements within Diablo. Diablo 4 takes an approach to simplifying the character screen by combining the character's stats, equipment, and their current inventory into a single UI panel. This panel can quickly be opened to provide information about our character stats, which gear is equipped, and also what new loot we've picked up. We'll start by taking the character panel and dividing it into smaller pieces that better outline the interface's building blocks. At the top here we have the character details section, which contains the stats on the left side, consisting of the name, level, and title, as well as a profile and materials and stats button, our character's primary stats, the character's attributes, and on the right side we have our equipment by slot for our character, along with a preview of what our character looks like. We have our equipment slots for armor and jewelry, and last we have our weapon slots. For our bottom section we have the character's inventory. This is split up by tabs for inventory type, and our inventory grid, which contains a maximum number of slots based off our type of inventory. Then we have our currency section, which is broken down between our gold, red dust, and obols. Now that we've studied the different components of our UI, we have a direction that we can attempt to recreate within Godot. We can start with a UI scene that lays out some control nodes to break up our UI into proper sections. The way that we're dividing this, we can easily use the margin container for padding, and the V-box that we'll name sections to distribute our sections between the top character details section and their bottom inventory section. We'll then wrap each of these in their own parent control nodes, as well as set their distribution using the layout container sizing stretch ratio. Here we'll set 3, and in our inventory we'll set it to 2, which means that we're using 3/5 and 2/5 of the container respectively. Note that the stretch ratio is the sum of all of the sibling elements. We also have a color rectangle and a texture rectangle that we're using to define the background color and overlaying a texture for some detail. You'll see that I use this technique a few times to get a little bit of a grainy feel on the background without needing to create it as an external texture. To do this, I set the background texture to a gray color, and for this texture rectangle, I use a noise texture 2D. I let that set to the scale of the type of texture I'm going to use. For this, I'm using a fast noise light with a type of Perlin noise, and then I just tinker with the width and height settings for the style I want. Next, we have our character details nodes, which itself has a margin container for some additional padding. That contains a detail section, which is a HBox container. That contains our stats and character equipment sections. You'll notice we also have a control node for our level display, which itself contains a color rect and texture, as well as our label node. This allows us to position and set the rotation for our container of our level, which more closely matches what Diablo 4 has. We're also using the same pattern of a color rectangle with a texture rectangle for our textured pattern. And again, our stats and character equipment have container sizing stretch ratios set to determine how wide of a container they should fill. Here the stretch ratio consumes about 1/3 and 2/3 respectively. Now for our stats, we have a fair bit going on. Stats parent container is a VBox container, which allows us to distribute the nameplate, materials, and extra stats, the primary stats, as well as attributes. Each of these nodes use a layout of a margin container with a VBox containing the elements. That's just for basic alignment. But our primary stats and our attributes have some custom node scenes. This allows us to make our scenes a little bit more reusable. For example, if we first jump into our primary stats, we can look at our custom stat icon item scene. This simply contains an icon to highlight its stat type and contains a stat name and value. You'll notice we're using these on the scene to export these values to create a more reusable scene to simplify our stats node tree. And the node tree itself is fairly small, and the script is fairly short as well if we look at our script. This has some basic behaviors for our export to set the value and update our labels using a custom function, which just updates the text value of our stat and value labels, as well as updates our icon's texture based off the icon we define. We come back to our attributes and look at our attribute scene. Here we have an attribute item. This is a straightforward name string and value that we can again export and handle with a simple tool script. Here we have similar behavior for our export for our attribute name and our stat value that again update the labels respectively. Again, we're updating our text value. And if we go back, let's look at our character equipment. Here you can see again, we have a color rectangle, gives us a bit of a background texture. Then we rest that within a margin container. Inside there, we have a simple paper doll character background, which is just simply a texture rectangle. Next, we have a background shadow, which is simply using another texture rectangle using a gradient texture that we then define with a radial scale. Then we have our VBox container, which again is aligning our elements in a list fashion. This contains our equipment for our armor, jewelry, and weapons. You'll notice that these slots are using our custom UI item icon. And this is a custom scene that we'll cover here shortly. So altogether, this gives us a nice sectional layout with our stats on the left and our equipment on the right-hand side. Some simple previews of our item icons. Now our inventory section contains a background setup with the color and texture, again providing us with that grainy texture. And inside here we have a simple VBox container for laying out our inventory tabs, our inventory grid, as well as our currencies. All of the inventory stuff is contained within this inventory's margin container, as well as another VBox container for alignment. And within our grid container, we have a simple color rectangle to give us a background. Then we're using a simple grid to give us the slot alignment based off the number of slots in our grid. And then our inventory grid, which actually has a custom script. Now this inventory grid script will populate our inventory instance and create the UI elements for each item that we have within our inventory. We can briefly look at this script from a high-level perspective, then we'll take a step back and review what we're going to implement for our items and that item data structure. We'll note that our inventory grid holds a reference to an inventory class and a packed scene for our UI item icon. And most of our functions are dealing with this custom item class.
Stay a while and listen.
So this is the point in which the project was no longer only a UI study of Diablo IV and recreating that UI layout within Godot 4. Instead, I wanted to populate items both in the character's equipment slots as well as within my fancy inventory grid that we just looked at. At first, I started with the idea of just mocking up a template of a single item, or maybe just a few icons of armor and weapons, and then just call it a day. And this is where the UI item icon would begin. But I couldn't just settle there. I had to have the full dopamine hit of random item rarities, random rolled stats, sockets, gems, and that sacred and ancestral tier. Not only did I want the inventory icons to be randomized, I wanted to be able to hover over each item icon and get the tooltip showing all of my random stats, the item name, the fancy colored borders and backgrounds, and all the extra details that we may want to pack into our item descriptions. I wanted to see if I could not only mimic the UI, but also some of that data structure that Diablo 4's itemization might use. Let's begin by examining items within Diablo 4. If we look at the different categories of items, we have gear in the form of armor, weapons, and jewelry, and socketable items such as a gem. All items at their core are going to have some common attributes such as their name, the rarity, tier, and category, an image icon, the description of the item, and some items will have level requirements, whether or not it's tradable, any specific class restrictions, whether or not the item is account bound, and the sell value of the item. And moving beyond our common attributes, we require more information for our gear and socketables. We can define our gear to extend an item containing additional details such as the item power, the upgrades, current and max rolls, the number of affixes that have been rolled, the sockets, as well as the durability. And while extending our gear for armor, the types of armor we have are chest, helm, pants, footwear, gloves, and shield. And for weapons, we have axe, bow, crossbow, dagger, offhand, mace, staff, sword, scythe, wand, and polearm. And for our jewelry types, we have a ring and amulet. And last, for our gems, we have the types of diamond, sapphire, ruby, emerald, amethyst, and topaz. When looking at gem qualities, we have crude, chipped, normal, flawless, and royal. With all that covered, we have the elements for what we need to create some custom resources. In Godot, we can start with a base class for our item that extends a resource. And for our base item, we'll be setting up exports for our variables that we want to be able to modify within that resource. We also set up some helper variables that use the getter functions to generate things like our class strings and returning our compound category from a function that we can define later within the class's definition. We have some enumerators for our character classes and categories, as well as some of the item tiers and rarities. We also set up a static array of rarity colors that will help us set up the branding of our backgrounds and borders for our item's icon within our UI. And here we can see the get compound category and get type helper functions. And next, we'll extend our item by creating a gear class that extends our item custom resource. And we can see that our gear class has quite a bit going on, but this is where itemization really takes off. We're defining the structure for our item power, the affixes, and other gear specific variables. We set up some lower and upper limits to determine things like the affix counts, the max upgrades, max sockets, our breakpoint tiers, the tier ranges, and we also have some functions for setting up things like rolling our item stats using the roll function and roll affixes. When we roll, we are setting up a number of our sockets and upgrades, and this item is based on our ranges, and then we can slap on some affixes by calling the roll affixes function. This will leverage our affix class to populate some of the strings in our description. Currently, there's no real behavior in this example, but it fits nicely in the UI. Our affix code is a bit more involved so that we can randomize based on flat percentages and stat-based. The end result should be an affix with a string that can be passed through as a template. This structure can be extended much further to provide more of a mechanical benefit for our stat system if we really wanted to flesh it out for our needs. Now, luckily our gear class handles the bulk of the heavy lifting for data and some of the functions for our equipment, but our armor will have some unique distinctions. Notice that we export a type that's based off our type enumerator. We also have the armor texture that we can reference along with the armor's icons, mapping the frame specific indexes to the specific armor types. We also set the category as being our armor category, and our getMaxSockets function is defined as part of overriding that gear implementation, which allows us to vary based on the type of armor. And lastly, we override our getType function to allow our helper to base the type through that enumerator. Now, our weapon class is almost identical in structure as our armor class. Instead, we're defining our weapon types and using a weapon texture and mapping it to its weapon icons. The functions and category are all the same approach as our armor implementation, and we update the getMaxSockets function and getType functions to handle our helpers. And big surprise, the jewelry class is set up just like the rest of our gear, with only a ring and amulet type, and the implementation being much simpler. Next, let's look at our item types for Socketable and Gem classes. First, our Socketable is a simple new base class for future Socketable items, gems and hearts for Season 1, and who knows what else they'll be adding. Here we're simply defining our getCompound category to return as a Socketable string, and with such little code, we can see our gem implementation. You can see that our gem class is doing a little bit more of the heavy lifting for our Socketables right now, but that's how things are for this example. If I were to implement more Socketable items, I'd likely extract those shared behaviors into the common class, but for now, gem is all that we have. And for now, gems is all we have. Again, we can see that we're exporting our type. We have the quality definitions for the enumerated quality types. We have a set level requirements. We have our gem texture. We have a colors array that maps the colors, which will be used within our shader to recolor the icons. We define our category. We get the color from our colors array. And we initialize this with a Boolean for our stackable, the value, and our image texture. And again, override our compound category and get type functions. And now that we've created all of our data structures for our items, let's take a look back at our inventory grid and see how that we can leverage that data to build out our inventory and drive our UI with it all. Here we're looking at a high-level overview of our inventory grid, but let's take a deep dive here at this variable for the inventory. Here we can see we're creating a custom class for inventory that extends a resource. This is a basic data structure for storing our items and keeping track of when we add or remove one or more items. We have signals that we will emit when we add an item or remove it from our inventory. We'll track the maximum capacity, the stored number of items, and we can see we've got some convenience methods for finding, adding, removing, and checking the availability or count of an item, as well as a convenient sort function that'll organize our inventory based on this custom function. And back in our inventory grid, we can see we have a UI item packed scene, the prefixes and suffix strings as an array. And within our ready function, we are creating an instance of our inventory, looping over a range between 30 and 33, calling this generate item to get our item data, adding the item to our inventory, sorting it. Then we loop over each item within our inventory and call our helper function, which will instantiate the UI item icon within our node tree, add it to our scene, and we'll add our signals for adding and removing items and calling the respective helper functions. We look at the corresponding generate functions. You can see that our function will take the category of item that we want to generate and match that to populate the gem and return. Or if it's a type of gear, we'll create the proper item class and set the type to create the atlas texture from the proper texture and region, and then the remaining common variables. And then at the end, we will return our item. We're also calling the generate name function to get the proper string for the name of our item, as well as to set it to our item details. And if we look at those helper functions that we defined for adding and removing the items, we can see that these simply create and manage the instances of our UI item icons and track the children whenever they need to be removed from the inventory as well. Our UI item icon is our connection between the data and UI layer. We'll be assigning the item to the item variable of our UI element, and it'll do all the heavy lifting for mapping the data to the proper components and delegating how we view our tooltip. Our node tree consists of a root control node. We have all of our item highlight texture, item icon texture, and a quantity label, as well as a container for all of our sockets and whether or not the item icon is being hovered. These will all be mapped within our code for binding data within our script. We export out our item with a setter function so that we can connect the item's change signal, letting us know that any of the item data may have changed, such as its quantity. And when this happens, we'll be calling our update item icon helper function, which is the staple of this script. We're binding all of our onReady variables to connect references to variable names to all of our nodes within the scene tree. We have our overlay shader, which if we look at our shader editor, we can see that our item icon uses a simple color fragment shader that takes in the base color and our blend color and does a mix of the two colors. I'll likely be covering shaders in more detail in future videos. We also have our socket scene to instance for each socket within this item. We can see that our socket scene is a simple control node with a socket background and a gem icon, indicating when the gem is slotted. The script for this is simply setting the item of the gem in question with a helper function whenever the gem gets updated. We have a gem colors array for the different types of gems. We have a texture for our gem and a similar shader to our item icon that uses the color overlay And back in our UI item icon, we can look at our update item icon function, which as mentioned does all of the heavy lifting. First, we have to ensure that we have an item defined. If it's a gear item, we want to ensure that it has its rolled stats. Then we can duplicate our shader material, which for the gem icon, we'll apply the shader as we previously did for the UI socket scene. For the icon's background texture, we'll be setting the material based on the item's rarity. And for any gear, we'll also have the highlight texture, which will show for the sacred and ancestral tiers. We then loop over all of the gear's sockets and create an instance of our UI socket, and we'll ensure that it all gets added to our scene. And any stackable items will be showing the quantity label when the value is over 1. And lastly, we want to ensure that our mouse events are connected for any of our UI's functionality, such as our on hover, enter, and leave. Now this behavior is all implemented for our UI tooltip. Here we have our UI control, which sets up a static reference to our UI, making this a singleton class. There are many ways to set up a global or singleton, and here I'm experimenting with Godot's static variables for our _UI variable. Note that our onHover functions that they delete and recreate our UI's tooltip scene, as well as ensuring its position in an item is properly defined based on which of the UI item icon item we're currently hovering from our inventory grid. These functions all call to our delete tooltip helper function, which will handle the cleanup and removing from memory. This also ensures that any of the signals that are connected get disconnected for that previously hovered UI item icon. Our tooltip is also doing some of the data binding similar to our UI item icon and has a more involved node scene tree and an accompanied script. Our tooltip's root is a control node, and within it we have a variety of VBox containers which will outline our equipped container, which allows us to control the equipped plate's visibility within our script. And then inside that we have our info panel, which has a variety of background and spacing nodes, such as margin containers and VBox containers. All of this controls, again, the background colors, textures, and spacing for our border and margins. For our background textures for gradient and border, we have an internal reference that allows our script to update with a shader to control the color based on the rarity of our items. And inside there we have the item icon, and then a VBox container for all of the additional attributes and item properties, each of which is bound with a unique name so that we can reference it within our script. The VBox container allows us to nicely stack all of these item attributes. Here we can see that our tooltip exports a color for its background based off the rarity of our item and the item that is bound to this tooltip. After all of our onReady statements for binding our nodes to variable references, we can look down and see that a bulk of our work is actually being done within our update tooltip values function, which is called when the node is ready. Here we can check the existence of our item. Then we just simply set the item's icon texture, set up our shader material based on our item rarity. This is also applied to our gradient rectangle and border rectangle textures. We also set the color overrides for our item name, category, and upgrades label. Then we can map over our node map and match any potential string templates and toggle any visibility based on some of the Boolean states. You note how we're using some getter functions to define some of these dictionaries and their corresponding templates. Next, we also loop over any of the gear affixes and add the corresponding labels as we need inside of our stats list. And similar to our UI item icon, we look at the item category, and for the gem, we set up the shader for the icon, and for gear, we set up our sockets. This is again using the UI socket scene that we then add to our scene tree. And last, we can set up our equipped plate visibility and update our container sizing. We'll also ensure that our signal is bound so that when our info container is resized for any reason, that we'll be updating its sizing again by calling the set deferred on the size. And because we've set up our tooltip as a tool script, within the editor, we can see a real-time preview of our tooltip. And if we run everything, we can see that our inventory grid generates a full inventory. And when we hover over each of these items within our grid, we can see a tooltip. It has all of those items' respective details. Be sure to check out the great pixel art that I've used in this example, linked in the description down below. Now, what about all these drag-related functions within our UI item icon? Well, Well, this allows us to drag and drop the items around, and depending on our logic, can allow for behavior to occur, like say slapping a gem into an empty socket of an item. You can see that our _getDragData function defines what happens when we start dragging an item. We'll set our dragging item icon to our item at about half alpha, and then we'll return a data object that contains our item's ID and item variable. And then this data object is then passed between our canDropData function and our dropData function. These test what we can do with the data object. And in the case of our item, we can choose to drag around and where to drag to. If we test that the item that we're dragging is a type of socketable, and the current item icon's item that we're dragging over is a type of gear that has a free socket, then we can safely drop this item. When we do successfully drop on our UI item icon, we tell our gem class to remove it from our inventory and tell the gear to apply the item to the socket. This will update our UI item icon to reflect those changes. So if we do drag and drop our gem, we can see that the UI item icon is updated to reflect the newly socketed item. And to wrap it up, I threw together a fun little dungeon scene using Kenny's Dungeon Asset Pack, link in the description below, and rendered it out as a static background. I added a texture rec with this render as a background to our UI scene, and added a little gradient to transition between our UI details panel and our game rendered image. This gives it a nice look and more atmospheric to match our UI. And with all that completed, we can see that we have an exciting working prototype of Diablo 4's itemization and UI likeness within our Godot 4 scene. Our implementation for itemization lets us randomize the items based on the categories and types of items that we may want. We have fancy UI icons that can update based on the data, as well as showing a tooltip upon hovering over that icon. We can drag and drop icons around for a socket mechanism, and this can be used to drag and drop to organize the inventory or swap the gear in our equipment slots, or whatever else we'd want to do to implement within our game. You could even reintroduce the grid-based mechanic from the older Diablo games and have fun with a Tetris-style approach. This project was much more involved than our previous topics, but it was really fun for me to work on. I hope that you were able to take away some ideas on how you can take an existing idea and break it down into understandable components that you can then implement for your own games. Join us over on Discord if you want to discuss the project in more detail. If you want to support my work, consider sharing with others, becoming a member, or leaving a one-time donation on Ko-fi. Links for everything are down in the description below. Thanks for joining me on this adventure. Thanks for watching, and happy coding.